Mr. Calix here from Math Magicians, and we will continue with our course of pre-calculus. As promised from the last video, these are your answers so that you can check if you did them correct. Now we're going to continue with the last part of the real numbers. Remember that this is prerequisites for pre-calculus. We will start with basic properties of algebra. We will start by defining these three expressions that you see here. Variables. Number one is a letter or symbol most commonly represented with the end of the alphabet or a Greek letter. For example, the most common ones are X, Y, Z, and the Greek letter can be theta. Then we have a constant. A constant is a letter or symbol that represents a specific number. An example would be the square root of 2 or -3, or a symbol that represents a number. Then we have algebraic expression. It's a combination of variables and constants that involve addition, subtraction, multiplications that we represent them with a dot, and divisions that we represent them with a quotient. An example of an algebraic expression can be 3x minus 4, which includes a constant, a variable, and any of these expressions. With this, we continue with the next part. Basic properties of algebra. Properties of algebra, you can see them in this table. They are 5. Commutative property. First, let's read this here. It says, let U, V, and W be real numbers, variables, or algebraic expressions. Number 1 says commutative property. The way that you add or multiply, or the order in which you add or multiply your factors, doesn't affect your answer. For example, U plus V is equal to V plus U, or U times V is equal to V times U. Then we move to associative property here. The same thing, but with another element or another factor. Okay, if you group them, but you're making an addition, the answer does not affect. The same thing happens in multiplication. If you multiply first U times V, and then multiplies the W, is the same thing as multiplying first V times W, and then multiplying the U. Identity property is when you get the same answer. Addition, when you add, or the addition property of identity, when you add to any number a 0, your answer is the same number. When you multiply to any number a 1, your answer will be the same number. That moves us to the inverse property. When you add two numbers that have different signs, your answer is going to be 0. And multiplication is when you multiply a number by its reciprocal, the answer is going to be 1. But that is when the variable is not equal to 0. Distributive property of multiplication over addition and subtraction. It's very easy. You just have to multiply the number that you have outside with every factor that you have inside, and that would be your distributive property. With this table, we can answer the two exercises that you see here on the bottom. It says, use the distributive property to write the factored form or the expanded form of the given expression. As you can see, this one is factored. How do we know? It has parentheses. This one is expanded. How do we know? It doesn't have parentheses. So the first one is factored. We have to write it in expanded. And to write it in expanded, what we're going to do is that we're going to multiply by distributive property. When you multiply by distributive property, like in this case that they are variables, what you do is that you just write them together. A times x to the square is ax to the square. A times b is just ab, or a times b. Okay, so that will be your answer for the first one. For the second one, as we said, we have to write it in factored form. Factored form means that you have to find what they have in common. What does these two numbers have in common? They both have the a to the cube. You open a parenthesis and then you just separate everything from a to the cube. like eliminating the a to the cube. What do you have? Z plus w. And this would be your factored form. This leads us to the next part of the video. The next part is properties of the additive inverse. Here, let u and v be again real numbers, variables, or algebraic expressions. You have your properties and you have some examples that we have here illustrated already. Number one, or property number one, says when you multiply a negative to a negative sign, the answer is going to be positive. Or when you multiply two numbers that have the same sign, the answer is going to be positive. Like for example, here it says negative times negative 3 is equal to 3. When their signs are different, their answer is going to be negative. For example, negative 4 times 3 is negative 12. Or you can say 4 times negative 3 is negative 12. So when they have different signs, the answer is negative. When they have the same sign, you just copy the two bases or multiply the two bases and your answer is going to be positive. For example, negative 6 times negative 7, the answer is 42. When you multiply 2, a base, a negative 1, you change their sign to negative. For example, the base 5 times negative 1, we change it to negative 5. When we multiply a negative outside a parenthesis, it's like if you use a distributive property for signs. Negative times positive is negative, and negative times positive is negative. You can see that here, negative and negative, because the negative was outside, and then you just make your addition because they have the same sign. Your answer is going to be negative 16. This leads us to the next slide. The next slide is exponential notation. Let a be a real number, variable, or algebraic expression, and n a positive integer. Then a to the n is a times infinite numbers of a, because we don't know what n is, n factors. So it's a n factors, where n is the exponent and a is the base. And how do we read it? It's read as a to the nth power. The exercise says identify the base of the expression. Okay, it's only asking for the base, but we're going to identify both. First, the power. The power is your factor. Power I'm going to represent it by p, and as you can see, your power here would be 7, indicating that the base that I'm going to represent by b is going to be a negative 2. We continue with our next slide. Okay, the next slide says integer exponents. We're going to start discussing what are properties of exponents. It says this table here. We're going to start here. Then it says let u and v be real numbers, again, variables or algebraic expressions, and m and n be integers. All bases are assumed to be non-zero. Okay, so all the bases that you see here, all the variables that you see here are non-zero. Then you have your first property. It states that u to the n power times u to the n, when you're multiplying two bases with two different powers, what you do is that you add the powers, as you can see in this exercise. 5 to the third power times 5 to the fourth, we copy the base and we add our powers. Number 2, when you have a quotient or a division, you subtract your powers. You copy the base and you subtract your powers. 9 minus 4 is 5. When the power is 0, it doesn't matter how high or how low the number is, but the answer is always going to be 1. When the power is negative, you use a reciprocal. You send it to a denominator to make the power positive, as this example. Number 5, when the power is for two bases that are different, as in this case, you just separate them. U to the m, v to the m, as you can see in this exercise. 2z to the fifth power, they are both separated. 2 to the fifth power, z to the fifth power, and then you evaluate your number. 2 to the fifth power is 2 5 times, actually 32. Number 6, u to the m to the n. When you have a power over a power, or a power inside parentheses with a power outside parentheses, you multiply your two powers, as you can see here. X to the second power to the third power would be 2 times 3, copy the base, multiply the powers, that is 6. Number 7, when you have a quotient both to the same power, you just copy them separately. U to the m, b to the m. As seen here, a over b to the 7th power, they are both to the 7th power. With this, we're going to continue with the exercise. Okay, for that, I'll move this here so that we can solve it. It says, simplify the expression. Better yet, we'll separate this from here so that we can have much space. Let me just erase here. Okay. It says, simplify the expression, assume that the variables in the denominator are non-zero. So we're going to start solving it. There are many ways in which you can solve this. I like to make all my powers that are outside my parentheses, I like to make them positive. So I'm going to use the reciprocal, indicating that I'll change my denominator for my numerator and my numerator for my denominator. My new written way would be, and that makes my powers positive, will be y to the 6th power, x to the negative 4, and all this now is going to be to the positive 2 power. That was your denominator. Now, this goes over your numerator. Your numerator now is x to the, sorry there, let me just change that, over x to the negative 3, y to the 2, but now the negative 4 becomes positive. Okay, you can do this. Or you can just say, no, I just want to multiply. That is completely up to you. Now, I multiply the powers as if they were distributive. If I multiply my powers, I have y to the 12, x to the negative 8, over x to the negative 12, and y to the 8. Then remember your properties. It said that when you have powers as a quotient, you can subtract them. So this is like saying y 12 minus 8, okay? Because you can see that they both have those powers. And x would be negative 8 minus negative 12. If we start solving this, we will have, this one is already almost solved, y is equal to 4, and x would be negative 8, negative times negative, we just saw that property, it says that it's positive 12. And then we solve this subtraction, y to the 4th times x to the 4th. This is my answer. With this, we're going to continue with the next slide. Scientific notation, okay? We continue with scientific notation. It says, any positive number can be written in scientific notation. C times 10 to the m, where 1 is less or equal to c, less than 10, and m is an integer. Okay, what is this explaining? It's saying that your c always has to be 1 from 1 or greater than 1, equal to 1 or greater than 1, until 10. Okay, but it cannot be 10. It has to be between 1 and 10. Okay, but it cannot be 10. In other words, it says, write the number in scientific notation. So we can make our exercise. We're going to use this definition. The mean distance from Jupiter to the sun is about 483,900,000 miles. Okay, so we have to convert this into scientific notation. Remember that the last digit, or the first digit in this case, this digit has to be greater or equal to 1, but less than 10. Okay, that was the definition of scientific notation. So let's start. I'm going to erase so that I can use this number and not copy it again. Now, let's start. What I do is that I put a decimal point at the end, and then I just start counting. 1, 2, 3, 4, 5, 6. I do not stop here, 7, 8. I stop here because 4.8 is less than 1, I'm sorry, greater than 1 and less than 10. Okay, so we can say that my answer here is 4.839 times 10. How many times did I move? We moved exactly 8 times, right? 8. And the answer would be in miles. Okay, the answer would be in miles. The second exercise says, write the number in decimal form. Okay, the other way around. Okay, we're going to write it as a decimal now. We have 3.33 times 10 to the negative 8. But I'm not going to copy that times 10 to the negative 8, just the 3.33. When you're converting into a decimal form from a scientific notation, what you do is that you check if the power is positive or negative. If the power is positive, you move to the right side. If the power is negative, you move to the left side. In this case, we move to the left. 1, 2, 3, 4, 5, 6, 7, 8. All these empty spaces are zeros, and I always like to put a 0 here. That means that my answer is 0. We count how many zeros we have. 1, 2, 3, 4, 5, 6, 7 zeros. So we locate them. Let's count them. 1, 2, 3, 4, 5, 6, 7. We're correct, and we copy that 3, 3, 3. This would be my answer in the decimal form. Okay, with that, we continue with the next exercise. The next exercise says, use the scientific notation to simplify. Okay, so we have to simplify this answer, this problem. So what we're going to do is that we're going to include everything that we just learned. The first thing that I'm going to do is that I'm going to multiply these two numbers, and the last thing would be divide. To multiply those two numbers, I'm just going to use their bases right now. 3.7 times 4.3. If we multiply these two numbers, would be 7 times 3 is 21. I carry a 2. 3 times 3 is 9 plus 2 would be 11. 4 times 7 is 28. I carry another 2 again. 4 times 3 is 12 plus 2 would be 14. You add this will be 1951. And you have two decimals that I will be including fundamentals for the guys or for the people that need help in fundamentals. If we include the decimal, it will be here, 15.91. So, and then you remember that when you have two powers, you add them, or in this case, subtract them because they have different signs. So this is like saying 15.91 times 10 to the, it will be negative 7 plus 6 over 2.5 times 10 to the 7. With that, we can subtract our powers in our numerators. 15.91 times 10 to the negative 1 over 2.5 times 10 to the 7. Okay, we have that. Now, we can convert it as a scientific notation says here. We move our decimal. We will have 1.591 times 10 to the negative 1 plus 1 because we moved our decimal one time to convert it into scientific. Over 2.5 times 10 to the 7. Okay, now once we have that, we have to make our subtraction of powers. We'll have 1.591 times 10 to the 0 power over 2.5 times 10 to the 7th power. Okay, with that, we don't have any more space, so we're just going to continue with the next slide. So we can have space. So what we had was 1.591 times 10 to the 0 power over 2.5 times 10 to the 7. We have to make a division. What am I going to divide? These two numbers here. If we make our division of that decimal, that is 1.591, and we start dividing. The 1.5, what I like to do is that I like to make them whole numbers. It's easier to divide. The amount of times that I move this number here is the amount of times that I'm going to move this number here. That means that we're going to have 2,500, and inside we will have 1,591. As you can see, 1,591 is less than 2,500. We add a 0 and a decimal point. With that, we start dividing. 2,500 times 6 is actually 15,000. We can subtract this. We have 910. Since 910 is less than 2,500, we add another 0. 2,500 times 3 now tells you that it's 7,500. We make this subtraction, is actually 1,600. Once you subtract it, since 1,600 is less than 2,500, we add a 0 to make it greater so we can continue dividing. Again, it's 16,000. If it's 6 times that we know already that was 15,000. We make this subtraction, it would be 1,000. We add a 0, and we know that it will be 4. So it will be 10,000 here, indicating no remainder. Okay, I'll continue with a different color here. So we have 0.6364, and this, remember that it still divided these numbers here. What is 0 minus 7? So I'm going to copy it here. I'll erase this and I'll copy it again. Let's erase this. Okay, we'll copy it again. It says 0.6364 times 10 to the what? It will be 0 minus 7, actually negative 7. But because this number here is less than 1, it has to be 1 or greater, we have to move the decimal point 1 time to the right, indicating 6.364 times 10 to the negative 7 minus 1. So your answer is 6.6364 times 10 to the negative 8. This will be your final answer. With that, we continue with our next slide. Your next slide is some exercises so that you can start practicing for the next video. As always, these exercises will be solved in the next video. And don't forget, math is magic. Thank you for watching.